Welcome. Let's take a look at how we can apply the mean value theorem in context. In this application, we have traffic on a segment of highway that is being monitored by two public safety officers equipped with radar. The officers are positioned 5 miles apart on the highway. As a truck passes the first officer, it is clocked at 65 miles per hour. 4 minutes later, the second officer clocks the truck traveling 65 miles per hour. If the speed limit on that segment of the freeway is 65 miles per hour, should the truck receive a ticket? So you'll notice that there are no mathematical functions or variables explicitly defined in this context, but let's take a look. Let's say the first officer is located here and the second officer is located here. So this is number 1 and number 2. And the truck is traveling between the 2 points, and we know that he traveled 5 miles because the 2 officers are spaced that far apart in 4 minutes. So where are the functions, and how might we reason about this being associated with the mean value theorem? Well, we can talk about the position of the truck at time t. So f of t could be the position of the truck at t minutes. Okay, so we could say that, so let's assume that our truck passes the first officer at time t equals a, and then passes the second officer at time t equals b. Now, if we want to know whether or not the truck should get a speeding ticket, we need to know the speed of the truck over that interval. So we could start by finding the average speed, the average rate of change, or the average speed. So our average speed would be our position at time b minus our position at time a over b minus a. We can also refer to this as the change in position over the change in time. Now, the mean value theorem tells us that provided our function is continuous over the closed interval, so over the interval from a to b, can we assume that the position of this truck is a continuous function? And that would seem a reasonable conjecture. Also, can we assume that the position function is differentiable over that time interval? We don't have any information that leads us to think otherwise. The truck is just simply driving down a freeway. There are no mention of sharp corners or anything like that. So it seems reasonable that the position of the truck should be differentiable. So that means that there is a time in that interval. There is some time between A and B, some time in those 4 minutes, such that the actual speed of the truck is equal to the average speed of the truck. So that means that there exists a time c such that f prime at c equals the change in position over the change in time. Now we know that the change in position here was that the truck went 5 miles down the road, and that the truck did that in 4 minutes. Now, to change this into a form where we can judge the actual speed of the truck, we need to convert minutes to hours. So let's go ahead and convert. We'll say 1 hour is equal to 60 minutes. So we'll convert that in the denominator. And so what we end up with is 5 over, I'm going to write it as 4/60ths for the moment. And our units here are miles and hours. Now my 4/60ths, that can simplify. 4 goes into 4 once and into 60 15 times. And so when I divide 5 by 1/15, that's equivalent to multiplying 5 times 15 over 1. And we have miles per hour. And 5 times 15 is 75. So there is at least one time in that interval within those 4 minutes where the truck was traveling at 75 miles per hour. So we could say, yes, in theory, the driver of the truck should receive a speeding ticket for going 75 miles per hour, or for traveling at a rate of 75 miles per hour. I hope you find this helpful.